Well, hey everybody, Mr. Reeves back with you as we continue to look at lesson 18.4, equations with many solutions or no solutions. So in my previous video, I introduced this lesson and we looked at each type of problem, explaining why it worked the way it did. And now we're going to do like we always do. We're just going to dive in and do just a whole bunch of problems. Here we go. All right, so I am, if you're interested, on page 580 in the Accelerated Math 7 textbook. All right, so here we go. Right at the beginning, it says to use the properties of equality, to simplify each equation, then tell whether the final equation is a true statement. All right, so here we go. Remember, a true statement would be when the left side equals the right side. Well, there's actually nothing to simplify here. All right. So if we take a look, we have 3x minus 2 equals 25 minus 6x. Well, if I were to solve that equation, 3x minus 2 equals 25 minus 6x. Well, I would add 6x to both sides. And that would give me, these would cancel. I would get 9x minus 2 equals 27. All right, then I would add 2 to both sides, and I would get 9x equals 29. And then I would divide by 9, and it's not going to go in evenly, so I would get x equals 29 over 9. All right, so again, did I write that down right? So 3x minus 2 equals 25 minus 6x. I added 6x to both sides. 9x minus 2. I added 2. Oh, that was, that was not 27 plus 2. It was 25 plus 2. Which was 27. And then when I divide by 9, I get x equals 3. All right. So x equals 3. The statement is true when x equals 3. All right, it's not always true. If x is 1, it's not true. If x is negative 4, it's not true. But x equals 3, when you solve it, that makes it true. All right, okay, let's take a look at the next one. 2x minus 4 equals 2 times the quantity of x minus 1 plus 3. Remember, we're going to distribute before combining like terms when we simplify here. When we do that, we get 2x minus 2 plus 3, and that simplifies to 2x plus 1. So take a look at what we have here. On the left-hand side, we have 2x minus 4, and on the right-hand side, we have 2x plus 1. All right, so if you watched the previous video, you got this discussion where, why did that appear right there? We've got 2x will always equal 2x, right? But negative 4 will never equal 1, all right? So this one is false, right? This one is false because negative 4 does not equal 1. This would only be true. This would only be true when 2x minus 4 equal 2x plus 1. That can only be true if negative 4 equals 1, and that is never true. So this one is false, all right? So the best thing to say about this one would be, I would say this statement is sometimes true. All right, this statement is false or is never true. All right, and they didn't give us one, but the third option would be always true, and that's when both sides are exactly the same. All right, so how many solutions are there? In example 2, there are no solutions. All right, after simplifying an equation, Juana gets 6 equals 6. Explain what this means, all right? Well, there's an equation. There's an example of an equation, that is always true. That means it has infinitely many solutions. Infinitely many solutions. All right, there you go. Okay, let's look at some more problems. Tell whether the equation has 1, 0, or infinitely many solutions. All right, now I can tell you right off the bat. Do you see how this is 3x and this is x? Both of these are already simplified. Do you agree 6 plus 3x is completely simplified? X minus 8 is completely simplified. Once it's completely simplified, if the variable terms are different, All right, if the variable terms are different, that means it has one solution. Okay, obviously it cannot have infinitely many solutions because those sides are clearly different. All right, and it's not going to ever have no solution unless those variable terms are the same and the other are different. So this one has one solution. All right, we could go through and solve it and find what that solution is, but they didn't tell us to do that, so I'm not going to. All right, so here we go. On this one, I'm going to distribute. Well, 4 times 2x. There we go. 4 times 2x, that's going to give me 8x. All right, and 4 times 1 is going to give me 4. So take a look at this left-hand side. What do we have? 8x plus 4. Take a look at this right-hand side. What do we have? 8x plus 4. Those two sides are exactly the same. Therefore, what do we have? We have infinitely many solutions, and the reason we have infinitely many solutions is those two sides are always equal. All right, this is always a true equation. This is sometimes a true equation, and when you have a never true equation, that's when it has no solution. All right, so write a linear equation in one variable that has infinitely many solutions. All right, remember, if it's infinitely many, it should be always true. All right, that's what we're looking for, always true. So start with a true statement. 10 is equal to 10. All right, so if it's going to be always true, you start with that true equation. All right, add the same variable to both sides. So 10 plus x, all right, is going to equal 10 plus x. We added x to both sides. Plus x, all right? I'm going to write that again a little neater. 10 plus x, all right? All right, add the same. Now what are they adding? Add the same constant? Is that what they want us to write? Add the same constant to both sides. 10 plus x plus 5. All right, combine like terms. All right, so we get 15 plus x equals 15 plus x. All right, kind of silly example if you think about it, because you could just look at it and see. The ones I like better are when they look different, but they're actually the same. I like those ones when they look different, but they're actually the same. But that's a case where you have infinitely many solutions. Okay, so here we go, one that looks different, but it's going to be the same. So if we want infinitely many solutions, again, what does that mean? That means it should always be true. And that means we want the left-hand side to equal the right-hand side, always. Okay, so here we go. If I distribute here, what do I get? I get 2x minus 2 plus 6x. All right, combining like terms on this side, I get what? 8x minus 2. So this side right here is equal to 8x minus 2. If it's going to have infinitely many solutions, then this side here should also equal 8x minus 2. All right, well, if you take a look here, what's 4 times minus 1 going to equal? That's going to be negative 4. So that 4 times negative 1 is going to give me negative 4 plus 2, which is negative 2. So that takes care of that part. But what else do I need? I need 8 x's. So how do I get 8 x's with a 4 out here? I put 2x here, right? So my answer that I'm looking for is 4 times the quantity of 2x minus 1 plus 2. So if I had this expression, again, if I were to apply the distributive property, I would get 8x minus 4 plus 2, and then combining my like terms, I would get that 8x minus 2. So my right-hand side equals my left-hand side, so it has infinitely many solutions. All right, this one right here, we want no solutions, which means we want it to be never true, right? Well, if you take a look here, if I distribute, what am I going to get? 3x. I've got 3x here, right? So that's going to give me 3x. When I distribute here, 3 times 4 thirds, well, it sure is nice that denominator cancels with that, and I get 3x minus 4. right? So if I want no solution, why not put 3x plus 4? All right, 3x minus 4 will never equal 3x plus 4. In fact, I could put anything here. I could put anything except, you know what I can't put? Anything except negative 4, because adding negative 4 would be the same as subtracting 4, and that would make them the same. But we want it to be never true, because 3x always equals 3x, but negative 4 will never equal plus 4 or anything else except for minus 4. All right, are you starting to feel more comfortable about with these equations that have infinitely many solutions, or no solutions, or one solution? All right, so a lot of times it involves simplifying. So if I distribute that negative through, what do I get? I get negative 2x minus 2 minus 1. All right, and if I simplify that, I get negative 2x minus 3. So that's the left-hand side. Over on the right-hand side, if I simplify this one, I got negative x minus x. If I distribute that, I get minus 3, right? So what do I get? Negative 2x minus 3. We'll take a look at the left-hand side. What do you have? The left-hand side is negative 2x minus 3. The right-hand side is negative 2x minus 3. So what is true about this equation? This equation is always true. And if it's always true, then it has what? Infinitely many solutions. All right? What about this one? Again, let's go ahead and distribute here. And we get negative 2z minus 6 minus z equals, and then when I distribute here, I get negative z minus 4z minus 8. All right? Okay, so negative 2z minus 3, that's going to give me negative 3z minus 6. And over here, I'm going to get negative 5z minus 8. So negative 2 minus 1 is negative 3. So negative 3z minus 6 on this side. Negative 5z minus 8 on that side. Okay? Compare the variable terms. This is negative 3z. This is negative 5z. All right? So this is an equation that is sometimes true. All right? Anytime you have those variable terms and they're different. When the variable terms are different, it's going to have one solution. When the variable terms are different, it's going to have one solution. When the variable terms are the same, in fact, when the entire thing is the same, it's going to have infinitely many solutions. And when the variable terms are the same, but the other part is different, that's when it's going to have no solution. I have a sneaking suspicion that's going to happen on this one right here. But we'll see. 3 times 2m, that's going to give me 6m minus 3 plus 5. And over here, I'm going to have, when I distribute, 6m plus 6. So this gives me 6m what? Plus 2. And this side gives me 6m plus 6. We'll take a look. It's exactly what I said. Those two are the same, but those two are different. So this equation will be true when 2 is equal to 6, but 2 never equals 6. So this one has no solution. All right? So when the two sides are exactly the same, infinitely many solutions. All right, when the two sides, the variable terms, are different, it will have one solution. And when the two sides, the variable terms, are the same, but the rest is different, that's when it has no solution. No solution. All right? All right, if I want this one to have one solution, then I know that the variable terms have to be different, and they specifically told me they want x to be negative 1. So if I simplify this, I get a 5x minus x, that's going to be 4x, and then minus a negative 2, that's going to be plus 2. And I want it to equal 2x minus something, right? And they want the solution to be negative 1. So think about it. The solution is what makes the equation true. So what do I get on the right-hand side when I put in negative 1? I get negative 4 plus 2, which is negative 2. All right, so what do I want? I want 2x minus, I'm going to call it y, and I want the answer to be -2 when x is -1. All right, so I'm taking this here. I'm going to put that -1 in there, and I want the sides to be the same. The left-hand side we already know equaled -2, so I want the right-hand side to be -2, so I'm going to put that -1 in there. That's going to give me -2 minus something equals -2. Well, -2 minus what? 0, isn't it? -2 minus 0 is -2. So what do we have here? We have 5x minus x minus 2 equals 2x. If I did it correctly, that equation should have a solution of -1. Well, again, if we simplify, what do we get? We get 5x minus x, 4x plus 2 equals 2x. All right, now normally I would subtract the smaller one from the bigger one, but because I don't like having a side be empty, I'm going to subtract 4x from each side. 2 is equal to -2x. Dividing both sides by -2, what do I get? I get x is -1. All right, last one I'm going to do on this video because this video is getting long, so I'll do a second video after this one. All right, infinitely many solutions. Remember, if it's infinitely many solutions, it should always be true. All right, so that means both sides need to be exactly the same. Let me try this again. We want it to be always true. All right, always true means these two sides are exactly the same. So again, if I distribute here, I get -x plus 8 plus 4x. All right, simplifying that, what do I get? I get 3x plus 8. So this left-hand side simplifies to 3x plus 8. So this side over here also needs to simplify to 3x plus 8, because if it's going to have infinitely many solutions, they have to be the same. All right, so what do I have right here? I've got 1x, and what do I need? I need 3x's, so I'm going to need an x. So that gives me 2x, right? Plus x gives me 3x, but I also need an 8. So what do I need? I need plus 4, right? So if I have 2 times x plus 4 plus x, if I distribute, I get 2x plus 8 plus x. That gives me 3x plus 8. Ka-chow! There we go, all right? 3x plus 8 equals 3x plus 8. All right, so there are some more problems I want to do that are on the next page, but because of this video going long, I'm going to go ahead and make a third shorter video for this lesson 18.4 on equations with many or no solutions. Until next time, have a great day. Bye.